Nice having you again, my friends. In this video, we're going to be looking at the solution to question 6 part E on the May 2012 CSEC Math Exam Pass paper. Here they're asking us to describe fully the single transformation which maps triangle LMN onto triangle ABC, and that's an easy 3 marks. Okay, so here we have it. We have our object LMN and we have the image ABC, which we had looked at in the previous video. All right, so you could look at that if you haven't seen it as yet, how we drew this triangle. Now they're asking us for the transformation that maps LMN or connects LMN to its image ABC. Now when you're asked to describe a transformation, now basically at this level they are testing us on 4 basic transformation. And number 1, that's a translation. Number 2, we have a reflection. Number 3, we have an enlargement. And number 4, we have a rotation. Okay, now let's figure out which one of those would be this transformation that they're asking us to describe. All right, now under a translation, let's check a translation and the properties of a translation. Under a translation, the orientation of the object and the image doesn't change. For example, if this triangle LMN is looking in that direction, then after it undergoes a translation, then the image will be also looking in that direction. Okay, if you notice, in this case it's as if you flip the triangle ABC. You flip triangle LMN rather to get the triangle ABC on its back. It's like as if it's lying on its back, so it's not a translation. Now let's check the second transformation, which is a rotation. No, sorry, my bad, which is a reflection. Now under a reflection, my friends, we know that a property, well, 2 properties, basic properties of a reflection is that object and image must be facing each other. Now if you notice, the object, which is LMN, is not facing the image ABC, vice versa. Okay, and also object and image must be the same distance apart from the mirror line. Okay, so obviously that's not happening, so it's not a reflection. Let's check the third one, which is an enlargement. Well, obviously it's not an enlargement because under an enlargement the size would change. Okay, and if you notice, ABC and LMN is of the same size. And in part A of this same question, question 6, we had looked at when LMN underwent an enlargement to produce its image PQR, which is still here on the screen. Okay, so having said that, we have ruled out 3 types of transformation, so obviously it must be a rotation. Okay, now if you notice, and one quick thing we could use to establish that it's a rotation, we could match corresponding line segments. If you notice, LM, this line segment LM, would correspond with the line segment AB, because it's as if you would turn the triangle LM on its back like that. Okay, so this AB would correspond with LM. Now if you notice, LM is a vertical line and AB is a horizontal line, and a horizontal line meet a vertical line at an angle of 90 degrees. Okay, and for example, my y-axis is a vertical line, my x-axis is a horizontal line, and if you notice, those 2 lines meet at an angle of 90 degrees, and I've just marked that. So obviously this is a rotation 90 degrees, and since this is the object and it's in the first quadrant, and this is the image and it's in the second quadrant, it's as if we flip it going back that way. Okay, so it would be going in an anti-clockwise direction. So we have established that it's a 90-degree rotation in an anti-clockwise direction. So the third property to describe a rotation is to find the center of the rotation. Okay, now let me just do a quick trick to show you how to determine the center of rotation. I'm just going to choose 2 corresponding points, one on my object and one on my image. Now I'm going to choose the point N, so my object point N, and I'm going to find the coordinate for N. Now when I come down on my x-axis, that's a 2, and when I go across on my y-axis, that's a 1, so that's 2, 1. Okay, my friends, and I'm going to find out its corresponding image point. Now if you notice, the point C would correspond with the point N. Okay, so those 2 points are corresponding points, just as the point M would correspond with the point B and the point L would correspond with the point A. But you don't have to do it for all 3. You could just do it with a pair, as I'm doing. So I'm saying the object N is mapping onto its corresponding image, which is C, and the coordinate for the point C is really, and let me open my bracket, this point C is -1, 2, okay, which we have established earlier, -1, 2. So we have N mapping onto C. Alright, now if you should look carefully, my friends, it's as if on the object we have 2, 1, and on the image we have -1, 2. Now it's as if they flip around the values, okay? So basically for 2, 1 they would flip it around to get 1, 2, okay? And then it's as if they change the sign on the image. So I had 2 positive values on my object point. Now the X value is negative on my image point, okay? Now the thing about it is this: when you have a unique relationship being shared between the object point and its corresponding image point, now the center of rotation is the origin. And what do I mean by that? The center of rotation is the point 0, 0, and I'm going to mark that point there, okay? So this is the center of enlargement. So when you're describing your transformation, number 1, you should have the type of transformation, which is a rotation. You must have the direction of the rotation, which is it's going in an anti-clockwise direction. You should have the angle of rotation, meaning it has rotated 90 degrees in an anti-clockwise direction. And you should have the center of rotation, meaning you should state that the center is 0, 0, or the center of rotation is the origin. Okay, my friends? And another way of checking that, you could actually draw lines from the corresponding object point to the center and then connect a line from center to the image point and use your protractor to measure that angle. Okay, so there, my friends, what I did, and you could use your pencils and ruler to just do the connection there that I've just did. Alright, and then you could use your protractor now and measure this angle here. Okay, and let me just show you quickly, just give you a quick sketch before I close this video. Here is my protractor. I'm placing my center. This is the center of my protractor. I'm placing it on the origin, where both orange lines intersect. And if you notice, my friends, the 0 line here, my horizontal line on my protractor, it lies on this line here on my on this orange line. And if you should measure the angle, if you should come up through here on this orange line, now if you notice, it would be going through that 90-degree angle that we spoke about. Okay, so pretty much it's that easy. We have measured that. So let's just switch to the next board where I'll describe the rotation, the transformation for you. So my friends, this is how you would have stated your answer for part E. The transformation is a rotation 90 degrees, and this is degrees, so let me just correct that quickly. 90 degrees anti-clockwise about the origin 0, 0. Okay, because the center of rotation is the origin. Alright, so pretty much hope that this was helpful. Feel free to ask a question if you're still not sure, and we'll get back to you as soon as possible. Bye bye.